When we have more than one device connected to a computer, like I mean to say IO devices, when we have more than one IO device connected to a computer, and when all the devices are actually generating the interrupts, then the problem is when we get more than one interrupt at a time, which one to service. So in order to implement this, we have to implement a system called as priority interrupt. We know normal interrupt what it is. So interrupt is nothing but whenever we are executing a program, if some signal is enabled, then we have to stop the program and go and service it. That is normal interrupt. Now this priority interrupt is when more than one device can raise a interrupt, then how we are going to, or whom we are going to provide the service to, right? So in order to make this clear, let's take an example. Let us assume that we have various IO devices. So like this, assume that we have memory, that is hard disk. Okay, instead of memory, let's say hard disk. Hard disk is one, right? And along with that we have mouse, and then we have a printer, and we have a keyboard. These four are there. Now whenever all the four are raising the interrupt, then whom should I give the highest priority, or whom should I service first, right? So according to this speed, I told you that hard disk has to be serviced first, right? In case if hard disk is not giving you the interrupt, and if these three are giving you the interrupts, then whom should you provide service to? Then I should provide this service to mouse. In case if these two are zeros, whom should I provide service to? Printer. If the interrupt is given by only by keyboard, then I should provide service to keyboard. Fine. So this is how our interrupt, this priority interrupt should work. The priority interrupt system should assign priorities to various devices, and then depending on which one is the highest priority device, it has to provide this service, right? So what I mean to say is, when you are executing a program, suddenly when you get the interrupt, you are supposed to go and execute the interrupt service routine of the program, or of the interrupt service routine of the device which corresponds to the highest priority, and then you are supposed to go to the next priority. Got it? Sometimes what happens is, initially you might get the interrupt from a low priority device like a keyboard. Then let us say you got an interrupt from keyboard, and when you are executing the interrupt service routine of the keyboard, suddenly you might get an interrupt from a high priority device, let's say like hard disk. Then you are supposed to leave it here, go to the hard disk service routine, finish it completely, and then come back, finish it completely, and then you come back to the main program. Are you getting this? So this is the interrupt service routine of, let's say, keyboard. Therefore sometimes even while you are executing interrupt service routine or processing an interrupt, you are supposed to be interrupted, right? Similarly, when a high priority device is being serviced, if a low priority device interrupts, it should not get interrupted, which means, see, in this case, assume that we suddenly get, we are providing the service to keyboard, right? Then we suddenly get an interrupt from hard disk. Then we are supposed to leave it here and then go to the service routine of the hard disk, and after finishing it, come back to the service routine of the keyboard and then complete it, right? In case if it is reverse, which means, let us assume that initially there is a hard disk and there is a interrupt request from hard disk, then you are supposed to provide the service to hard disk, which means you are supposed to execute the interrupt service routine of the hard disk. Okay, one more thing. In general, in most of the scenarios, it so happens that every device will have its own service routine, which means in your memory, at some address there will be interrupt service routine of hard disk. Similarly, at some point there will be interrupt service routine of mouse, and then there will be somewhere interrupt service routine of printer, and at some point there will be interrupt service routine of let's say, what is the other one, keyboard, right? So depending on what is the interrupt we got, we are supposed to go to that particular interrupt service routine and we are supposed to execute that functionalities, right, or those instructions. Got it? So now what is that I'm trying to say is, when you are executing the interrupt service routine of a low priority device, when you are executing this code, there might be a possibility that you get an interrupt from a high priority device. Then you are supposed to leave it here and then go to that and then execute it, right? So there are various issues here. So one issue is, how are you going to connect these devices to the CPU in such a way that you will see their interrupts. Second thing is, when you see the interrupts, how do you know which device has given you the interrupt, and how do you know the addresses of this? Let us say address of this one is 100 and address of this one is 200, address of this one is 300, address of this one is 400. Now how do you get those addresses, right? So there are various methods being proposed. So I'll just tell you what are all the methods which are possible here. We are trying to implement priority based interrupts. Okay, PI means priority based interrupts. There are two ways you can implement it. One is software based implementation and the other one is hardware based implementation. See, whenever I say it is hardware based implementation, it doesn't mean that there is no software involved at all. Either it is software or hardware, ultimately the instructions have to be executed from ISR, interrupt service routine, which is a software, right? Therefore, whenever I say hardware based implementation, there will be some software also. But then whenever I say software based instruction, it means it is purely software based instruction, okay, implementation. Now how to implement this software based implementation is, whenever CPU gets an interrupt, it doesn't matter which device we got it from, it doesn't matter, always we'll branch to a default interrupt service routine, okay? Even if the interrupt is from keyboard, or if the interrupt is from memory, or if mouse, or if it is from hard disk, I don't care. Whenever you get any interrupt, we'll directly jump onto this interrupt service routine, and it is generally stored in a fixed location. Let us say it is stored in the location 000, right? Therefore we need not know what its address is. Its address is always fixed, which is 000, right? Now we go to that location. Here there will be code written which will initially find out which device has caused the interrupt, right? So in software based method, we are going to use something called as polling. So you know what polling is. We'll continuously ask the devices one by one. So now there is an interrupt, and so that function is being called. In that function, the instructions are written in such a way that we'll go and ask each device whether it is the one which has created the interrupt. So which means first we'll go and ask hard disk, right? So we'll ask hard disk whether it has created the interrupt. How will ask it? It is nothing but checking its status flags. If this is the one which has caused the interrupt, then we'll immediately branch here and service that. In case if this is not the device which has caused the interrupt, then the next one which will be polled or which will be consulted is the one which is next highest in priority, which means we'll go on asking the devices in their decreasing order of priority, and that is how priority will be implemented in software. Are you getting this? First we'll ask the highest priority device. If it says that no, I didn't create the any interrupt, then we have to go to the next one and we'll ask it. If this one says that yes, I am the one, then we'll directly branch to this particular location and we process the ISR of this. right? If this is not the one, we go to the next one. If this is not the one, we go to the next one. The order in which we poll the devices will decide the order of the priority, right? So the highest priority will get, the highest priority device will get the topmost priority, and then the next one will get like that. Okay, so what is the disadvantage of this method? Clearly one disadvantage is the time which it is going to spend there. So why do you think that it is slow? You can think about it. It is actually slow. The reason is, even if the device which has created the interrupt is keyboard, we have to ask all the devices and then come to this point, right? And what happens is, in order to poll all these devices, we have to execute some instructions, and so the time taken to actually get down to the problem and execute the interrupt service routine of the keyboard is going to be very, very high, and so that is a disadvantage, right? So the disadvantage of this software polling method is it is slow, right? And why do you think that we are using the polling method? Because we don't know which device has actually raised the interrupt. See, now there are two ways. Whenever we get any interrupt, there are two things we can resolve. There are two ways we can resolve it. One is called as vectored interrupt, and the other is called non-vectored interrupt. In case of vectored interrupt, the device which is providing the which has caused the interrupt is also supposed to provide us with the starting address of the interrupt service routine, which means if hard disk has created the interrupt, then the hard disk has to provide us with the address 100. Therefore, to make it easy for us to directly go to that ISR, right? If mouse created the interrupt, then it is the responsibility of the mouse to say that in order to process my interrupt, you have to go to the address 200. So if the device which has caused the interrupt, if it is providing you with the address, the starting address of the interrupt service routine, then it is called as vectored interrupt. In case if it is not providing us the address, if the device is not providing us the starting address of the interrupt service routine, and if we have to find it out ourselves, then it is called as non-vectored interrupt, right? So this particular software method will fall under the category of non-vectored interrupts, right? So what is non-vector interrupts? It is our responsibility to use polling to find out which device has given the interrupt, and also it is our responsibility to find out where the interrupt service routine for that particular device is, right? So in case if it is vectored, then there is no need, right? So the advantage of hardware interrupt is, hardware based implementation is, we need not use polling to find out which device has created the interrupt. We can easily find out which one it is, right? Therefore there is no need of polling, so we can find out the device easily, right? So it is faster, right? And the other one is, this one is vectored interrupt. This one falls under the category of vectored interrupt. So what do I mean by this vectored interrupt is, you can think of it this way: the device whichever raises the interrupt will also give us the address of its ISR. In case if it is the hard disk which has raised the interrupt, then we'll know that it is the hard disk without polling. Also we'll know the address of this 100, right? Then we can directly go here and execute it. Therefore it is very, very fast. There is no need of this default interrupt service routine at all. We need not go there, right? We can directly go to the problem and fix it, isn't it? Interrupt is a problem, we can directly go to it without beating around the bush. We can directly go to the code and then fix it. So hardware implementation is obviously the better choice. Now when we look at this hardware implementation, there are two ways we can implement it. So one way of implementing it is by using serial connections, serial connections, and the other way of implementing it is by using parallel connections, right? So this serial connections is also sometimes called as daisy chaining, right? So what is this serial and what is this parallel implementations, we shall see now separately. So in the next video we shall see what is serial and then we shall see what is parallel. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.